Say you are working on a project where you need to connect with AWS. Maybe you want to use S3 to store files, DynamoDB to store some data, a Lambda function to run a bit of a code. The moment you try to begin, AWS asks for a credit card. You haven't even written one line and you are already paying. And it gets worse. You can't test offline. Every time your script crashes, you're paying for that crash. Every accidental loop, every wrong region, every forgotten resource, it shows up on the bill. So most people end up mocking everything with fake objects. And then when they finally deploy to real AWS, half of it breaks because of real AWS does not behave like the mocks. What if I tell you there is a tool that solves this? It is called Floci. It is a small 90 megabyte container that runs on your laptop and pretends to be AWS. 47 services like S3, DynamoDB, Lambda, SQS, almost everything you would normally use. Same APIs, same responses, completely free. Which means you can finally build your project locally, test it end to end, and when you are really ready to ship it, the same code works on real AWS without changing anything. And in the next 5 minutes, I'll show you exactly how it works. Then I will run 4 live demos, S3, DynamoDB, a real Lambda function, a SQS queue, and one feature you cannot get for free anywhere else, multi-account isolation. But before any of that, let me show you one idea that makes the whole thing work. So here it is in one picture. When you write code that talks to AWS using 𝗣𝗿𝘁, the AWS CLI, Terraform, the CDK, anything, your SDK looks at one environment variable to decide where the request goes. And that variable is AWS_endpoint_URL. If you leave this variable empty, the call goes to real AWS, means a real credit card on the file and internet connection, real money for every API call, and the risk of accidentally touching production data. That is fine when you are shipping a real product, but it is painful when you are just exploring or building a proof of concept. Now look at the other side. If you set that one variable to http:/localhost/4566, that request now will go to Floci, a small container which is running on your laptop. The same 47 services that AWS provides, free, offline, and safe to break. That is the entire trick. Same code, same APIs, the only destination changes. You build your project against Floci, you test everything works, and then you ship to real AWS and behaves it the same way. No mocks, no surprises, no build when you are just testing things out. So now let's go to the actual demo. Getting Floci running takes exactly 2 commands. These are straight from the GitHub README. Now first pull the image. It is only 19 megabytes, so this is very fast. You will just type down docker pull Floci/Floci and latest. This will pull the latest image from internet to your machine. Now run this. Port 4566 on my machine maps to 456 inside the container. That port is the AWS endpoint. Every API call goes there. Now what I will do, I'll run this command. Basically this will set up the container for me. That is it. Floci is now running. Next, I will tell my AWS CLI to talk to Floci instead of real AWS. 4 environment variables. The important one is the first, AWS_URL, which will point to the local host. The others are region and dummy credentials. So Floci does not check the credentials. You can put up anything there. So I will just put these 4 commands: export AWS endpoint through localhost, AWS default region, access key, secret access, and I have put US East 1 test. That is something you can set up. And when you enter this, that is the whole setup. No AWS account, no internet connection, no billing. Everything is running on my system, and I'm mocking an entire AWS cluster. So let's start our demo. In the demo 1, we will create an S3 bucket and a DynamoDB. We will test the database connection. We will use standard AWS CLI commands, and let's see, we create a bucket, we put a file there and see how it works. So we'll simply run this script. Now the first step, what happens if you see when it runs this AWS S3, it creates a bucket called as uploads. So it makes this bucket, and after that we copy a file. So we take a local file and upload it as an object here. So upload AWS S3 will copy a text file.txt and will upload it to s3.upload. So it will go there. After that, we will list the bucket content. So we'll simply do AWS S3 and ls, and we will list down the file there. So we see that 70 file.txt is available there. So this technically shows we are able to upload to S3 bucket and we are able to source from there. Now we will test our DynamoDB creation. So we'll create a table called as user. So we use the standard CLI command AWS DynamoDB create table, and we will patch it to that particular S3 that we have just created right now. It will take some time and will create a table for you. Once it is done, now you can insert a row, for example, U1 and name, and you just use this AWS DynamoDB put item, table name, and item. So this information will go into that. And now you can scan the table as well. You'll use AWS DynamoDB scan and it will provide you the content of that table. So with this, what we see that we are able to create an S3 bucket, we are able to create a DynamoDB table, and which is, everything is not going to AWS. Everything is going to the Docker container that I've created using 𝗣𝗿𝘁. Now we will do the demo 2, where we will create a Lambda function around a Python function and see if that function actually wraps it up and returns the thing. So I'll just run this file. So now let's walk through over it. What is happening? I created a simple Python function handler, which basically returns just your name, hello world, right? Now, the step 2 is you just run this. It will run this hello 𝗣𝗿𝘁 handler function. And after that, it will create a Lambda function, AWS Lambda, and it will take this function, patch it inside this Lambda function. Now, once the function is created, we will test it. So we'll wait till the function is active, AWS Lambda wait function active. And now once the function is created, I'll simply invoke the function with a payload. So I'll say, for example, name 𝗣𝗁, and I will just run it and it will provide me a response, hello 𝗣𝗁 from the real Lambda runtime. So again, we are able to see that we are also able to spin up a container. We are able to create Lambda function and get the real responses just like we do from AWS. So in demo 3, we will first create a queue. The 𝗣𝗁 will return the queue URL. If you see, we have created this AWS SQS this, and it returned me a queue URL. Now the step 2 is the producer side. It will send 3 messages here, a process order 1, process order 2, process order 3. And each one will come back with a message ID that you can see, just like SQS works. Now the step 3 would be to receive all 3 consumer side, receive up to 3 messages. There they are. Like if you try to see, we have received this one, we have received this one, we have received this one. And you can also check your queue depth. So you can build your worker against this exact endpoint. When you deploy, you don't change the code. You just remove the endpoint override and it really talks to SQS. So this is about the 3rd demo. Now let's go to the 4th demo. We'll create the multi-account isolation. Now in the demo 4, I will create multi-accounts and I will test them. So you really don't need an actual AWS account. You can basically mimic it by writing any 12-digit access key because you're not actually creating on AWS. So you'll just give the step 1 as account A key this, and it will create a bucket. So for example, you provided this and you created a bucket, team A data. Then you created account this, and then you will get the team A data. Then you want to switch to account B, so you'll provide another account ID, and now you will switch to that account. So account B will create its own bucket. Now you can switch up between the account A and account B, and this is how multi-tenant isolation is happening. One account, one ID is not affecting other. So if you want to test all that locally, let's say you have different products, and for each product you want to have your own tenant space, you can test all that using local 𝗣𝗁𝘁, and then you can push to AWS. So that is 𝗣𝗁𝘁 47 AWS services, real container, Pack, Lambda, and RDS, multi-account isolation, MIT license, completely free. It works with every AWS SDK, Python, Node, Java, Go, Rust, whatever you can think of, and with Terraform as well, and CDK without changing a single line of code. So to start using it yourself, pull the image, set AWS_endpoint_URL to localhost, and then it will start working. That's all. Build your next project against 𝗣𝗁𝘁, test it against real AWS, and you won't even need to pay money to test your POCs. The repository link, it will be present in the description. Try that and let me know how it goes with you.